The way the resonator works is it tries to tune to the natural frequency of a pile. Everything in the world has a natural frequency. What we do is we tune to the natural frequency and we push and pull the pile at the exact time that when you do so, the pile turns into a spring. It takes much less power to drive a pile, and it also does it with zero ground vibration. One main advantage of the resonator is there's independent control over amplitude and frequency. When you're operating, you can change the frequency and the amplitude to whichever value you want. Our machine has an auto function built into it. You press auto and the computer on board will take over the frequency and change it to wherever the natural frequency of the pile is. When you're driving, there are several factors that will change the natural frequency. As it goes deeper, the ground resistance and damping will actually change the natural frequency. If you go through different layers of soil, it'll also change the natural frequency. So when you're operating in auto mode, the system will automatically account for these changes and maintain the system resonating across its full operating range. Our original goal was to actually create a machine that was as powerful, if not more powerful, than conventional machines. When we developed the machine, we determined that one advantage was that when you resonate, you actually install a pile with zero ground vibration. This wasn't something that we originally were trying to achieve, but it was a benefit that was a very, very important benefit in the end. So, because we can drive a pile with zero ground vibration, it is very important and very useful for settings and job sites in urban areas or areas where there's vibration sensitivity. Typically, if you're driving in a job site where there's existing infrastructure and there's pipelines or machinery around it that vibration will damage, then you can actually drive a pile with our machine and not worry about any damage or any ground vibration. A resonator compared to an eccentric mass machine is typically much smaller and uses much less power. The resonator uses a piston cylinder device, and it actually starts and stops at its operating frequency. This also allows for greater power in the entire operating frequency range and enables us to resonate a pile. Your eccentric mass machine moves, pushes and pulls, starts and stops the entire pile, whereas the resonator turns the pile into a spring and stretches and compresses the pile. This then allows us to drive a pile more efficiently, typically quicker, and with zero ground vibration. We're now ready to get our machines into the field and into users' hands. We've recently partnered up with DIESEKO to help us do this. DIESEKO is a company that has been operating and pile driving for many, many years, and we're going to use them to help develop the industry expertise and the support needed to get our machines into the marketplace.